Hello and welcome to Software Testing from Scratch, brought to you by Eduonics. My name is Richard Martin. This is Chapter 4, Non-Functional Testing. So the topics that we're going to cover in today's chapter are usability testing, accessibility, performance, scalability and capability, security testing, internationalization and localization, compatibility and portability, maintainability and supportability, there's quite a few abilities in here, testability, disaster recovery and business continuity. Right, so let's get started. Usability testing. Is it fit for purpose? Usability testing will measure the capacity of the application to make sure it meets the user's needs. A good way to do this is something called hallway testing. I'm not sure how this term came about, but hallway testing basically means you stand out in the hallway and you grab people as they walk past and ask them to come and use your application. They don't necessarily have to know how it works exactly, but this is to make sure that there's no major showstoppers or things that will stop you from progressing with your testing. It's really good because you're getting an outside perspective from somebody who has never used the application before, and it allows you to feedback bugs as quickly as you can. I'm not saying that you should go outside and literally pull people out of the hallway, but it would be good if you could speak to somebody within management in your company and ask them if you could borrow a couple of people from different departments just to come and have a look at your application, give you a bit of general feedback. Again, as I've always said, other people are far likely to pick up on mistakes in your work than you are. So let's move on to accessibility testing, which is it's always been around, but it's even more prevalent in the last few years. I'm not sure why. It should have been prevalent years ago, but anyway, disabilities pose special challenges when working out how easy products are to use, because they can introduce additional experience gaps between users and evaluators. Accessibility evaluation must take into account what it's like to experience the web from a different perspective, from a different sense, different abilities as well, and of the various unusual configuration options and specialist software that enables web access to people with particular disabilities. Sometimes you have people with impaired eyesight to have very large screens, and each website is magnified kind of tenfold, or even sometimes the website will dictate to the user what's on there. Now, from personal experience, if you've got some text embedded in a picture and it's not actually selectable text, if it's actually part of the picture itself, a lot of the software won't work. Some websites have a separate disabled access or different accessibility levels, which would basically be just a text-only version of the website, which would let these dictation applications actually dictate to the user what was on the website. Without them, you're kind of segregating those users from being anywhere near your website. So as the final point says here, the goal in both usability and accessibility is to discover how easily people can use the website and feed that information back into improving future designs and implementations. If you knew something didn't work on your first release of your website or your application, there is absolutely no point at all in including that in the second release. You may as well use a release schedule to make good improvements, to fix issues that you've discovered with the first release. Accessibility testing should be top, if not one of the top priorities. Now we have performance load testing, which is quite a specialised sector, to be honest. You tend to find that QA companies would either employ a single person to do this, employ somebody to go on a training course to get them trained up on how to do this, or even hire in a third party to come and do some performance load testing. It's the simplest form of performance testing, really. Load testing is usually conducted to understand the behavior of the system under a specific load. The specific load is usually what would be expected in the real world, just to see how it would perform. The load can be the expected concurrent number of users on the application performing a specific number of transactions within a set duration. This test will give out the response times of all the important business critical transactions, if the database or application server or whatever you're testing is monitored, then the simple tests can within itself point towards bottlenecks in the application. For instance, if you have something like PRTG monitoring your web server and you notice that you have 2 or 3 people all running database queries at the same time, and then all of a sudden the CPU utilization goes up to 150%, which does happen. I know percentage means out of 100, but it does go up to 150. And all of your system RAM's used, then you know that there's a bit of a database problem there. And you wouldn't necessarily know that unless the application was being monitored as well as performing these load tests. We'll just quickly go through the points here as well. As I've said, it's the simplest form of performance testing, just to understand the behavior of the system, expected concurrent number of users on the application, performance of a specific number of transactions within a set duration, and response times of all the business critical transactions. Response times would be, if we take, say, a car insurance company website, for example, how long does it take from you pressing the submit button to getting a result back, with 1 user, with 10 users, with 100 users? And as I've said, point towards a bottleneck within the application software. Stress testing, slightly different. It's normally used to understand the upper limits and capacities within the system. This kind of test is done to determine the system's robustness in terms of extreme load, and it also helps the application administrators to determine if the system will perform sufficiently if the current load goes well above the expected maximum. There's been a few examples in the press about this, namely of websites, again car insurance websites, payday lending websites. As soon as their ad campaigns go live on TV, the website gets hammered. You would have 30-40 fold the amount of users using the website that were using it before, and unless it's been stress tested, 9 times out of 10 all these users going onto the website would actually perform a denial of service attack, and it would stop anybody from accessing the website at all if you're lucky. In fact, I think the best example I can think of is if your favourite band is playing in your local town and it's a big town, you know that the tickets are going on sale at midnight. How many times when you were younger did you try and get on that website at midnight and you would just get a white screen with that little sand timer just saying page waiting, page waiting, page waiting? That's because there's far too many people getting on the website. It hasn't been stress tested properly. Soak testing. So you pick up your computer and you put it in a bucket of water. Soak testing complete. No, I'm only kidding, don't do that. Don't do that. Soak testing is also known as endurance testing. It's usually done to determine if the system can sustain the continuous expected load. During soak tests, memory utilization is monitored to detect potential memory leaks within applications. Also, what's important but often overlooked is performance degradation, which is to ensure that the throughput and or response times after some long periods of sustained activity are as good or better than the beginning of the test. If you have 100 people all doing searches on the website for a minute, does that yield the same response times as if they were doing it for an hour as well? It essentially involves applying a significant load to a system for an extended, significant amount of time. The goal is to discover how the system behaves under a sustained load. Of spike testing. When you think of spikes, you generally think of electronic spikes. Exactly the same principle, but slightly different. Spike testing is done by suddenly increasing the load generated by a very large number of users and observing the behavior of the system. The goal of spike testing would be to determine whether performance will suffer, if the system will fail, or if it will be able to handle dramatic changes in load. So the best example I can think of for this is, previously if your 100 users had been using the system on and off for say 60 minutes, if you were to stop all of your users from using the system and then give them a 5-second window every minute to use the system, if you've got 100 users hammering your system just for 5 seconds, but they're doing it all at the same time, that will be classed as a spike. Ideally, a system should perform exactly the same under a spike test as it does under a load test. The significance and fast increase of users shouldn't really make a difference if it's being coded properly. But then again, if it's been coded properly, there'd be no need for these tests in the first place anyway. So I guess we won't go there. Now next we have configuration testing. How many times in your work have you had a notification saying that there was going to be some work, some out-of-hours work commencing during the night, and it wouldn't affect any systems, it wouldn't affect any users, and then lo and behold you come in the next day and nothing works. Hasn't been configuration tested basically. So rather than testing for performance from a load perspective, tests are created to determine the effects of configuration changes to the system's components on the system's performance and behavior. A common example would be experimenting with different methods of load balancing, for instance. If you haven't configured your load balancers properly, you're in trouble. Another configuration test would be something as simple as you want to add a new IPsec tunnel to your Cisco router. You're going to do it out of hours, so you don't have any impact because you know you have to reboot the system. However, you haven't tested it properly. You haven't bench tested it, so you don't really know what's going to happen. You just have a feeling that it's all going to go okay. So what if you putting that IPsec tunnel on destroys a different IPsec tunnel to your other main office? That would be an example of configuration testing. It's not often done, if I'm being honest, purely because in the example that I just said, these routers could cost you 15 grand a piece, and I'd very much doubt that many companies would have 15 grand to spare for an individual bit of equipment to do some configuration testing, but you never know, stranger things have happened. Next we have isolation testing. Now it's not unique to performance testing, but it does involve repeating a test execution that resulted in a system problem, such as a particular spike test. If you did a spike test, you discovered a problem, the spike test would then become an isolation test. Such testing can often isolate and confirm the exact fault domain, which basically means if you can do a 1 hour test and within 10 seconds of that 1 hour there's an issue, and you can repeat that 10 seconds every single time without having to replay the entire hour, then you're onto a winner there. You know exactly what's going to happen with that system. You know exactly which routine or which application's running at the time. It'll definitely be good if you can figure that out. Performance. This is a bit of a general thing. You must set your goals. Setting goals will allow you to demonstrate that the system meets performance criteria. Very important for documentation. Compare two systems to find out which performs better. If you have two versions of software, version A, version B, and version B is the current one in production, and version A is the legacy one, run the same performance tests on version A as well, just to see if your previous versions of software actually handled the tests any better. If they did, it might give you some pointers on where to look to fix the issue. Measure which parts of the system or workload cause the system to perform badly. Identifying the bottlenecks is the single biggest pain in the backside of any QA performance tester. Not only do they need to have a lot of software testing experience, but they need to be very on the ball at spotting these issues so they can do some isolation testing to repeat them. All these things are very important because without them, performance testing only becomes benchmark testing. Once you've done benchmark testing, you can then benchmark future releases against that, which is only truly then classed as performance testing. Scalability. This testing lets you determine how your application scales with increased workload. Suppose your company expects a 10-fold load increase on your server within the next 2 months. You might need to increase the server's performance and shorten the request's processing time to better serve visitors. If your application is scalable, you can shorten this time by upgrading the server's hardware. You can increase the CPU frequency, maybe even add more CPUs and RAM. You can improve the request performance by changing the software, replacing text file data with a SQL Server database. To find a better solution, first you can test hardware changes and then software changes after that to compare the results. Now, scalability testing gives the answers to the following kinds of questions. How do hardware and software changes affect the server's performance? And is it possible to increase the application's productivity by upgrading the server hardware? Ideally, it's much cheaper to upgrade the server software, Well, then again, maybe not if it's a Microsoft license, but then again. After that, you can go down the hardware route, adding more processors, maybe even replacing the entire unit if you have to, whatever is adequate to keep your system online. So, capability testing is used to find the boundaries within the application. How much can it take before it starts to go wrong? Very, very important form of performance testing here. For example, if you have a link that runs a sample of JavaScript like this, rather than putting that link in your HTML, add it with JavaScript. With this approach, browsers that aren't capable of running JavaScript will never see a broken link. So, is your website capable of being displayed on Windows XP IE 7? Is it capable of being displayed on iOS Mavericks with the latest Safari? All good capability tests.